Okay, this video is about factoring trinomials, but in this video there's going to be a leading coefficient other than 1. That means that this number in front of the x squared is not going to be 1. It'll be some other number instead. Okay, so let's look at our first example. So we're going to use 2x squared plus 5x plus 2. So there are multiple methods that you can use to factor trinomials that are like this. I'm going to explain it the way that I use in my classroom, but there are many other ways. So if you were taught another way, that's perfectly fine. Okay, so here's what we're going to look at. We're going to look at our first number, which is our leading coefficient, and our constant number, the one with no variable. And so the first thing we do is we start by multiplying those together. So 2 times 2 is 4, and I'm just writing this out to the side. Okay. So if you remember how we thought about this before, I need two numbers that multiply to give me 2. Sorry. They're going to multiply to give you the 4 instead. And they're going to add, since that's a plus, to give you the 5. So I need two numbers that multiply to be 4, but they add to give me 5. So that's going to be 4 and 1. I'm going to take these two numbers and I'm dividing by those two numbers I multiplied together in the beginning, that first and last number. So I'm going to divide by 2, and then I simplify if I can. 4 divided by 2 is 2, and then that's going to go with one of my parentheses, x plus 2. And then that second one, the 1 over 2, the denominator is going to go with my x. So this is going to be 2x plus that numerator number, 1. 2x plus 1. Okay, so let's look at another one, because this usually doesn't make sense until you've seen 2 or 3 examples. So let's say I have 3n squared plus 5n plus 2. So if you remember the first step, multiply the first and last number. 3 times 2 is 6. So I need something that will multiply to give me that 6. That's a plus, so we're still going to add to get the 5. So two numbers that multiply to be 6 but add to be 5. That's going to be 3 and 2. Divide them both by that leading coefficient number, divided by 3. Simplify if we can. 3 divided by 3 is 1. So my answer is going to be n plus 1 and 3n plus 2. Okay. Let's look at a couple more. So 2x squared plus 9x minus 5. So we're going to multiply that first and last number. 2 times 5 is 10, or negative 10 if you want to write it that way. So that's the number I'm multiplying to get. Since that's a minus, this time I need it to subtract to get that middle number. So I need two numbers that multiply to be 10 but subtract to be 9. So that's going to be 10 and 1. I need to make sure that I get a positive 9. So it's going to be positive on the 10 minus on the 1. Since I was multiplying to get a negative number, I need one of each sign. And then we'll divide them both by that first number in our problem. Divide by 2. 10 divided by 2 is 5. So we're going to have x plus 5 and 2x minus 1. Okay, so another example. 9x squared plus 6x minus 8. So we're going to multiply that first and last number. 9 times negative 8 is negative 72. That's what I am trying to multiply to get. But since that's a negative at the end, we're going to subtract. So I need two numbers that multiply to be 72, but subtract to be 6. And if you're doing this on your own and not just watching a video, you'd probably have to take a while to list your factors of 72, because it might take a bit to come up with those numbers. So those numbers are going to be 12 and 6. I need to get a positive 6. So positive on my 12, negative on my 6. Divide by my first number. Simplify if I can. I can't divide any of these completely into each other, but I can simplify my fractions. So 12 over 9, I can divide those both by 3, which will make that 4 over 3. 6 over 9, I can divide those both by 3. That's going to make that negative 2 over 3. And now I'm going to write that answer. So that's going to become 3x plus 4 and 3x minus 2. Okay, So let me give you one more example, which is going to kind of combine a couple of you may know about factoring. So let's say I have 3x squared plus 30x plus 63. All right, so one thing you want to look for, which you may not have thought about until now, is I need to, every time, look at these numbers and make sure that there's not a common factor. If there's a common factor that I can take out, then I really should do that first because that's going to make this easier. That was not a possibility on any of the other examples I'd shown you so far. So 3, 30, and 63, I could divide 3 out of all of those. So I'm going to put 3 out in front of my parentheses, and then I'm going to divide it out of each of those terms. So that's going to leave me with x squared plus 10x, since 30 divided by 3 is 10, plus 21, since 63 divided by 3 is 21. Now I keep that 3 out in front because that's the only way I can make it become what it started with, is if I distribute that out. Now, look what's in parentheses. Can I factor what is left inside the parentheses? So this is where I would think to myself, what multiplies to be 21, but adds to give me 10. And so this part's going to factor into x plus 7 times x plus 3. And we just keep that 3 that we factored out in front of all of it.